We are now to the last section of Module 4, 4D. We are still solving quadratic equations, and today we're going to learn our last method, which, to be honest with you, is my favorite method. So today, if we go to our notes, we're going to see that sometimes when we've seen this already, you cannot solve a quadratic equation by factoring or doing the square root method. Sometimes neither one of those methods work. Now, we did learn to do the complete the square method, but if you want to not use that method, you have another option. So, this is what happens. You're in college algebra, you're solving quadratics. The quadratic equation will not factor. It does not fit the rules. The quadratic equation cannot do the square root method. Now you have a choice. You either could use what we learned in Module 4C, complete the square method, or you can learn to use what I'm going to teach you today, the quadratic formula. Now let's think about the word formula. You've been working with formulas since elementary school in math. You know some basic formulas. To find the area of a rectangle is length times width, or base times height. Okay, to find the distance you travel, it's the speed times how long you travel at time. It's your distance equals rate times time. So we've been working with formulas. There's even formulas to convert degrees Fahrenheit to degrees Celsius. We've been working with formulas forever. I like formulas because all you do is plug and chug. You replace the variables with numbers and then you work the numbers out. So believe it or not, if you can use a formula to solve a quadratic equation, wouldn't that sound really simple? Let's look at the quadratic formula. The quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all divided by 2a. That is a formula. If you look at it, there's three variables, a, b, and c. And you're going to put numbers in those spots. And then you're going to work the numbers. So the hardest part about solving a quadratic equation to use the formula is memorizing that formula. So I'm going to teach you an easy way to memorize that formula. Let's go to the board. Now, I'm all for the quadratic formula because if you want to solve every quadratic equation and you want a method that's always going to work, this is it. If you want to know one way to solve all your quadratics, it's to use this formula. But I just said a minute ago, you have to have the formula memorized. So guys and gals, we're going to memorize it by something we all do. We all sing. I'm not the best singer in the world by no means, but if you learn how to sing this formula, you will have it memorized. It goes to the tune, Pop Goes the Weasel, which is the Jack in the Box tune. I'm going to sing it for you. So to memorize this formula, it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's try that again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. One more time. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Close your eyes and sing with me. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So that's your formula. Once you get it memorized, it's very simple to use. You're going to replace numbers on the right side. Now, you're going to replace 4 spots, 4 numbers. So everybody listen carefully. I have this written in your notes. There are 4 parts to this formula. The first part of the formula is negative b. Negative is a subtraction symbol. Subtraction means the opposite. So what happens is this spot goes the opposite of your number b. So if your b is 8, you'd put in here negative 8. If your b was negative 2, you put in here positive 2. So that's all that means. In this spot goes the opposite of your b. You would write the plus and minus, you would write the square root. The second part of the formula is b squared, which means take whatever your b number is and square it. So if your b is 8, you'd put a 64 there. If your b was -2 times -2 would be a 4. You put a 4 there. What's important to remember, guys, is basic arithmetic. Squaring means the number is always going to be positive. So in this spot should always be a positive number. The third part of the formula is all of this, -4ac. And that is all connected by multiplication. So you're going to multiply 3 numbers together. You're going to do -4 times whatever number a is, and then multiply that to whatever number c is. So in this spot is going to go 1 number. And the last part of the formula is 2a, which is 2 times a. So we're going to double a. So when you get done with this formula, there's going to be a number here, a number here, a number here, and a number here. You're going to see 4 numbers. And then we're back to arithmetic. We're going to work the numbers out. Okay, let's go back to the notes. So if you look, you're going to have to memorize that formula to solve a quadratic equation. And then you're going to have to understand the 4 parts of the formula. Now, here's the procedure you're going to follow. Okay, to solve using the formula, it says the equation must be set equal to 0. The reason why is you need all the terms on the left side to know where A, B, and C is. Because A, B, and C are going to be in alphabetical order. A is going to be the coefficient of x squared. B is the coefficient of x. And C is the constant. So when you have all your terms on the left side, you're going to see your A, B, and C, your 3 numbers. You're going to plug those numbers into the formula. And then once you get those numbers into the formula, you're going to follow this procedure. You're going to work the square root, you're going to work the numerator, and then get rid of the denominator. We're going to go through that process. It's not hard because it's working numbers, but it's very easy to make a careless error. So, let's look at an example. In fact, I think on my notes, I have 4 examples we're going to do on the board. So let's go to the board. All right. So here is your quadratic equation. Okay, it's quadratic, it has an x squared. Suppose you don't want to worry about how to factor a square root. If you want a method that solves all quadratics, you can use this formula. Step 1 is to make sure the equation equals 0. It does. Now, why you want it equal to 0 is because you want to know your 3 numbers for A, B, and C. And I would suggest you write them down. A is always in front of x squared. What's your coefficient? 1. B is always in front of x. What's your coefficient? 5. C is your constant. That's a -6. So you write down the 3 numbers you need for the formula. Now, I'm going to leave the formula up here. We're going to fill it in as we go. So we're going to write x equals. If you do not write x equals, you're wrong because that's what you're trying to find an answer for x. X equals -b means the opposite of b. That's your b5. What's the opposite of that? -5. Then you write plus or minus square root. Next part of the formula is b squared. Here's b, square it. What's 5 times 5? 25. The third part of the formula is connected by multiplication. Do not write -4ac on your paper. Work it out in your head. Take -4, multiply it to a. That'll be -4. Then take that and multiply it to c. Well, -4 times -6 is a positive 24. So guys and gals, don't assume because there's a minus in the formula, there's going to be a minus here. You're multiplying 3 numbers, and it could change to a positive. Does it matter what order we multiply in? No. If you want to do A and C first, 1 times -6 is -6. Multiply to -4, get positive 24. Then it's all over. And everybody watch carefully. If you write that, you're marked wrong. Everything up here is in the numerator, so that fraction bar is going to go all the way across. This says 2 times A. So here's A multiplied by 2. Now, once you get 4 numbers in it, it's arithmetic. It's following, please excuse my dear Aunt Sally. Do your order of operations. Well, we all know we do grouping symbols first. So we have to do what's inside here. 25 and 24 is 49. After we do the grouping symbol, we have to do the square root symbol. So -5 plus or minus. What's the square root of 49? Very good, it's 7. Now, You cannot add 7 and subtract 7 at the same time. We know a plus or minus means there's going to be two answers. So right here now, we're going to break this up into two parts. What this means is x equals -5 plus 7 over 2. And it also means x equals -5 minus 7. So that's important. Okay, we can't add and subtract the 7 at the same time. So we have to do one of each. We know we should both have two solutions. So now we'll work our numerator. -5 plus 7 is 2, and 2 divided by 2 is 1. There's your first solution. X equals 1. -5 minus 7 is -12, and -12 divided by 2 is -6. There's your second solution. As we talked about this whole module, we should always have how many solutions? 2. So these are our solutions. Now, it's very important to note, I knew working this that these two solutions we're going to get were going to be nice numbers. 1 and -6 are nice numbers. Now, the word nice is not a math word. Let's describe these numbers. Are 1 and -6 on our number line? Yes, they are. What do you call the numbers on the number line? Very good. They're called real. So we would say we have two real solutions. But if you remember, the number line's in two groups. You're either rational or irrational. We've heard these words growing all through algebra. You heard me in the previous module say these words. Rational has the word ratio in it. Ratio means it can be written as a fraction. Can either one of these numbers be written as a fraction? Sure they can. This number 1 as a fraction is 1 over 1. -6 as a fraction is -6 over 1. So we would say these answers are real and rational. So when they say describe the solutions, that's what they mean. Use the correct words. I knew I was going to get two real and rational answers because the most important part of this formula is right here, underneath the square root. What's underneath the square root is given a name. It is called the discriminant. discriminant. The discriminant. When you get one number underneath the square root, it's called the discriminant. Well, everybody look closely. Where is my one number underneath the square root? It's right here, 49. And what do you know about 49? Well, our discriminant is 49. And 49 happens to be a perfect square, right? So now we have a little rule. When you're working the quadratic formula, if what's underneath the square root, which is called the discriminant, if that number is a perfect square, you are always guaranteed to get two answers that are real and rational. Okay? Now, what I want you all to notice is if I said to solve this quadratic and I didn't tell you which method, because these are real and rational nice answers, I'm looking at this equation and saying, couldn't I just factored it and got these answers quickly? Yeah, I could have. So what I want you to notice is the quadratic formula is great, but it takes some work. If I'm in college algebra, just like in real world, I want you to get the answer quick and efficiently. And there was a quicker way to get the answer here. You could have used your factoring skills and said x squared is x times x. What multiplies to 6 and subtracts to 5 would be 6 and 1. I want to subtract and make a positive 5. The 6 would be positive, the 1 would be negative. I'd write my two linear equations. And I would get x equals -6 and x equals 1. Same answers, right? So what I want you to pay attention to is very simply, especially in class, if you're solving quadratics and they factor, most professors are going to factor them first. But if you're stuck and you forget to factor, you could always use the quadratic formula and get the same result. Isn't that great? All right, let's try another one. So let me erase all this and go to example 2. All right, our equation is x squared minus 2x equals -1. So again, if you want to solve this using the formula, the first thing is you have to know what a, b, and c are. So you have to have the equation equal to 0. So you're going to have to add the 1 over. So that's the first thing. To know the numbers a, b, and c, you have to have all the terms on the left side. Great. Now I can see a, b, and c. I highly suggest you write them down. A is always in front of x squared, it's 1. B is always the coefficient in front of x, that's 2. And c is your constant, 1. Now you're going to substitute them in the formula. And again, take it into the 4 parts. X equals negative b, that means the opposite of your b, which would be 2, plus or minus square root b squared. Let's square this. What's -2 times -2? +4. Let's do all this in one shot. -4 times a times c. So if you take a and c and multiply it, you get 1. And 1 times the -4 is -4. All over 2a. 2 times 1 is 2. That's all I need to see is 4 numbers. Now we're going to follow order of operations. Please excuse my dear Aunt Sally. We're going to work inside the grouping symbol. So 4 minus 4 is 0. Then we're going to do the square root. What times itself is 0? 0. And now we can't add and subtract 0 at the same time. So we're going to have here 2 equations. X equals 2 plus 0 over 2. There's the plus. X equals 2 minus 0 over 2. There's the minus. Now we can work it. Remember, you have to make the numerator one whole number first. So 2 plus 0 is 2. 2 divided by 2 is 1. Okay, so our first solution is x equals 1. Second solution, 2 minus 0 is also 2, and 2 divided by 2 is 1. Now, guys, we talked about this. We have 2 solutions. They're just the same number, so we don't need to write them twice. Okay, and that's okay. Sometimes that happens. We get the same answer out twice. So our solution is x equals 1. Now let's describe that. How many answers are there? There's 1 answer. Is that number on the number line? Sure, it's real. If it's on the number line, you have to say, is it rational or irrational? Can that be changed to a fraction or no? Sure it can. It can be changed to a fraction by writing 1 over 1. So this is a rational solution. Now, I knew we were only going to get 1 answer that was real and rational because I look at the discriminant. So everybody look closely. We made a definition. What's underneath the square root? B squared minus 4ac. When you get that all to be one number, that's called the discriminant. So if I ask you, where is your discriminant number? Everybody look at your work. Where's your one number underneath the square root? It's right there. So the discriminant is 0. And that's a rule. If the discriminant is 0, you will always get 1 answer that's real and rational. So instead of getting 2, you'll get 1. All right? So far, so good? Let's try our third one. All right, so let's erase. I like the quadratic formula because I like to sing, and I think it's easy to work with just numbers. All right, third example. X squared equals 8x plus 11. So again, it's quadratic, it has an x squared. If you look this time, the x squared's isolated. So somebody could be thinking, well, can we do the square root method? Because that was one of our other choices. Remember, to do the square root method, you need the x squared on the left and just numbers on the right. We can't square root 8x, so it's not going to work. So, whether I want to factor this or use the quadratic formula, I have to have everything set equal to 0. Now here's the question. Who do you move to set the equation equal to 0? Do you move the x squared to the right or the 8x and 11 to the left? Well, my rule of thumb is very simple. You always, always, always keep the x squared positive. Always. So I'm not going to move the x squared. I'm going to move the 8x and 11 by doing the opposite. I'm going to subtract them. And because none of these terms are alike, I write them in the descending order. X squared minus 8x minus 11. And these are going to cancel and equal 0. Now, we've already seen this equation. It doesn't factor. I can't multiply to 11 and subtract to 8. So I have to use the formula here. So I'm going to list my three numbers. What's A, everybody? Good, it's 1. It's in front of x squared always. What's B? Good, it's negative 8. And what's your constant C? Negative 11. Now we're going to fill in the formula. So we're going to sing x equals negative B. Negative B means the opposite of B. So everybody look, if that says negative 8, the opposite would be positive 8. Plus or minus square root B squared. Everybody take your B, negative 8, and square it. Negative 8 times negative 8 is 64. The third part, negative 4AC. That's all connected by multiplication. So I'm going to do A and C and multiply it. 1 times negative 11 is negative 11. And then I'm going to multiply to negative 4. And a negative times a negative is a positive 44. All over 2A. 2 times this A number is 2. The biggest mistake y'all are going to make is right here when you have to multiply the three numbers. Because you got to remember it's a negative 4 times the A times the C. Okay? Now we work what's inside a grouping symbol first. So 64 plus 44 is 108 over 2. Now this is the part you're not going to like. It all goes back to those basic algebra skills. We cannot leave a square root of 108. We have to break it down. So I'm going to have to go over to the side here and break down the square root of 108. The only way to break down a square root is to use your perfect square numbers. So here's another thing you have to have memorized from algebra. What are your perfect square numbers? They are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, ... The only way, we've already seen this in Module 3, to break down a root is to use a perfect square number. You don't want the smallest perfect square, you want the biggest. So you've got to be careful here. I agree, 4 divides into 108 evenly, but that's the smallest. The biggest perfect square that divides into 108 here is 36. So we would rewrite 108 as 36 and 3. What is the square root of 36? That's 6. It comes out. Can you square root 3? No. So what we're going to do is we're going to replace that square root of 108 with 6 square roots of 3. So now we have x equals 8 plus or minus 6 square roots of 3 over 2. So that's the hard part of working the quadratic formula. If you look, this was not a perfect square. So it had to be broken down. So we replaced it. Now, again, we got that plus and minus going on. We got to break this into two parts. So this is x equals 8 plus 6 square roots of 3 over 2. X equals 8 minus 6 square roots of 3 over 2. We got some more problems. We're supposed to add the numerator, but you can't add an 8, a whole number, to a 6 square roots of 3. They're not alike. So we can't add, but we can do division. And here's where the problem comes. It's careless mistakes. A lot of you are just going to divide the 8 by 2 and put a 4. But guys, it's got to balance. That bar goes all the way across. So it means to divide both of these by 2. Back in algebra 1 and 2, we made you rewrite this as 8 over 2 plus 6 square roots of 3 over 2. That's what that means. You're dividing both terms by 2. And then you would divide them. 8 divided by 2 is 4, plus 6 divided by 2 is 3 square roots of 3. And that's your answer because you can't add that. They're not alike. That's a whole number. That's an irrational number. Okay, now, you're going to say, well, do I always have to do that? Do I physically have to rewrite this as two fractions to do the division? I'm going to say, no, you do not. I call this, you can do it in your head, called by Mickey Mouse ears. When you get to this step, and you know you can't subtract what's in the numerator because they're not alike, and you need to divide by 2. You just got to remember, dividing by 2 means every whole number. So I'm going to circle, I'm going to circle, and I'm going to circle. And if you look like that, it looks like the Mickey Mouse ears you wear when you go to Walt Disney World. And if all 3 of these numbers can divide by the same thing, you're going to do it. So I can divide 8, 6, and 2 by 2. 8 divided by 2 is 4. Negative 6 divided by 2 is going to be the negative 3. We're going to leave the square root of 3. 2 divided by 2 is 1, but we don't get to write a 1 in the denominator. So there's my other solution. So it's not the formula. It's all the arithmetic where the mistakes are going to be made. You got to go slow. You got to understand that you have to add what's inside that square root and break it down. And if it's not a perfect square, you got to reduce it. And then you got to look and remember what this division bar means for both terms. Now, if you look at these answers, I'm going to ask you how to describe them. There are 2 answers here. We would say the solutions are 4 plus 3 square root of 3 and 4 minus 3 square root of 3. There are 2 different answers up there. Are they on the number line? Now, I know what's going to happen. Some of you are going to tell me, no, you've never seen that kind of number on the number line. You're right, you haven't. But if you take that in and type it in a calculator, you've got to remember what we talked about. A square root, when it goes in a calculator, gets converted to a decimal. So these in the calculator would be decimals. And are decimals on the number line, guys? Sure they are. So there are 2 answers here. They are real because they are going to be converted into decimals, which are on the number line. But they're not rational because they have square roots. They are irrational, which means they never can be changed to a fraction. So we have 2 real irrational solutions. I knew from the very beginning that these answers were going to be ugly, irrational, because look for my discriminant. Where is my discriminant? Remember, the word discriminant means the one number underneath the square root symbol. And there it is. There's your one number underneath the square root symbol. The discriminant was the number 108. And because that discriminant is not a perfect square, you are guaranteed to get 2 ugly or irrational solutions. So we have just now finished in 4 modules all the different ways to solve quadratic equations. I know, it's a lot. Here comes the fun part. In the next set of modules, we're going to use this to solve even harder equations. So yes, you have to know how to factor, you have to know how to square root, you have to know how to do the formula. Okay, I'll see you in module 5.